Problem 25. A point P is chosen at random inside square ABCD. The probability that AP is neither the shortest nor the longest side of APB can be written as A plus B pi minus C root D over E, where A, B, C, D, and E are positive integers. GCD, greatest common divisor of A, B, C, and E, is 1. And D is not divisible by the square of a prime. What is A plus B plus C plus D plus E? So, first, let's draw a square. And then let's say that we can plot dots like A, B, C, and D. Then in the question, we can plot P inside the square of ABCD. And the question said that AP is neither the shortest nor the longest side of APB. For example, for this triangle, it works for the question because BP is the shortest and AB is the longest for triangle APB. So, if we want to make AP as a neither longest nor shortest side, we should put a thing that AP is bigger than BP and smaller than AB. So therefore, we can put a line. We can cross out the half line of ABCD. Because if this line crosses over the side of AD, then AP becomes the shortest side of the triangle. So we draw a line over here. Then we also need to put the other problem. The problem is that if all the dots are not available to get the question right. So for example, what I'm saying is if we put this dot, and then if we draw the triangle of APB, then we can see AP is the shortest of APB. Then where do we need to draw a line so that it works as a question? To get a right answer for the question, we need to first draw a curved line of BD. If we draw like this, and then if we draw like curved line of BD, then we can see this area and this area works for the question because we can test it out as a dot. If we put a dot over here, then AP becomes neither shortest nor longest line of APB. However, if we put a dot outside of the area, it becomes the longest line. Also, if we put a dot besides the area that I'm sketching, then AP becomes the shortest side. So the areas I shaded are the available areas for P to become neither longest nor shortest sides. So we need to find the area of the shaded areas. So let's say the side length of each side is 1. If we say if it's 1, first we want to have the area for the shaded region. Let's try this one first. In order to have the value of the area, we should draw a line. If we draw a line, we could, let's say the shaded region is circle and the non-shaded region is triangle. Circle minus triangle is the shaded region. And the circle is a angle circle, which is ABG. The area of ABG, in order to have it, first the if this quarter circle was a full circle, then it will be 360 degrees. However, this is 60 degrees because we can use a triangular theorem. This side length of half of the AB is 1/2, and the line that cuts ABCD in half is 1. Then we can know that angle ABG is a 60 degrees by using the triangular theorem. Then the area of the ABG is and then we need to eliminate the triangle part, which is √3/8. So the shaded area for the first shaded region is pi/6 over √3/8. Now let's see the second part. For the second part, we need to minus from the half region of the square to the regions beside the shaded region. So the half of the square is 1/2, which is 1/2. And then for this area, we can say as √3/8 plus pi/12. And then this can be simplified as 1/2 minus pi/12 minus √3/8. Now we need to add both of the shaded regions. And this turns into 12. And then it's 6 plus pi minus 3/12. So we can know that A is 6, B is 1, C is 3, D is 3, and E is 12. If we add all the values, it will be 6 plus 1 plus 3 plus 3 plus 12, which is equals to 25. Therefore, the value of A plus B plus C plus D plus E is A, which is 25.